Hello, everyone. This is Del Pearson with Microwave Journal. Welcome to this EDI CON Online Educational Day. Our platinum sponsors are Samtech and Comsol, and our track sponsors today are Mini-Circuit CPI Electron Device Business, Altair, Keysight Technologies, and Murray Microwave. This session is 5G and 6G Internet of Things Outlook, given by Joe Madden, founder and lead analyst at Mobile Experts. Now I would like to introduce our presenter, Joe Madden. Joe founded Mobile Experts and serves as the lead analyst, and now I will turn the session over to Joe.
Hi, I'm Joe Madden, and I'm here to talk about 5G and 6G IoT today. And I'm going to take a little bit different tack than some of the other presentations in the EDI CON conference. I'm going to talk about technology, but I'm also going to talk about the business of how do we make 5G and 6G IoT work as a business. And how does that affect the RF requirements for the devices? All right, so let's dive in. First off, a quick bio on myself. I've been an RF guy for 40 years and been involved in cellular since the first days, since Motorola did some of the early systems in '89. And so I've been through all the G's. I started my company, Mobile Experts, 15 years ago to provide market data to the industry. And here's some examples of the kinds of predictions that my team and I have made over the last 15 years. We've predicted things like remote radio heads and massive MIMO and small cells, virtual RAN, open RAN, private cellular. And 9 times out of 10, we're able to predict where the market's going 5 years in advance and to do that strategically accurately. In some cases, very precisely. And so that's what we do, is we provide this kind of information to the RF industry, and about 150 different component companies making filters and power amplifiers and all kinds of RF devices come to us for insight about where the future is going. All right, so let's talk about where the future is going. When we look at the business picture of what's going on in wireless, we have a picture that looks something like this. So we have the smartphone business, which has risen and grown for 30 years. And, over the last 10 years, that's really kind of reached maturity. And I would say that we've reached commodity status with smartphones, where everybody has a smartphone. Everybody's already paying as much as they want to pay per month for that smartphone service. And so it's becoming increasingly difficult to find growth in the smartphone business itself. And at the same time, fixed broadband coverage is sort of a finite market, and we can have fixed wireless or satellite, which are growth opportunities for now, but those are incremental in nature, and they're really kind of limited in their ability to grow over the long term due to the number of people that are open to be covered in fixed broadband in these new cases. So, if I was a young guy, 22 years old and just starting out, I think I would probably focus my energy on the IoT business. One reason for that is that it's still in its nascent growth phase, and there's just a lot of things out there in the world that need to be automated. IoT, I think the role of IoT is changing from the human use cases associated with smartphones and fixed broadband to now trying to automate the world, whether it be cars or drones or sensors or machines that are operating, in some unknown place. There's a lot of things that need to be automated, and robotics are becoming a part of life. And as we automate those, and we need to use AI to train those things and connect them to the cloud and have them talk to each other, we more and more need these things to be connected. And so as far as wireless goes, this is where I see the next 20 to 30 year growth cycle. And I could see the IoT business becoming a $1 trillion business at some point in time. Okay, now let's put a few numbers up on the board. So first of all, in 2024, roughly 550 million cellular IoT devices were shipped. And that's going to keep growing. We see very steady growth over the last 10 years, and then very steady growth over the next 10 years, because this is a really broad market, and statistically, these are easier markets to predict because there's just 1,000 different things going on, and if one fails, another one goes, and so the overall total tends to grow in a steady way. But what I want to talk about today is really what limits this growth. What prevents the cellular IoT market from growing even faster than it is? And so that's really one of the questions that I want to focus on a little bit more. And what I'll start by saying is that IoT is not the smartphone business. We tend to use the same standards group, the 3GPP standards body, to develop standards for IoT. But honestly, I think that's a big mistake because there are very different needs in the IoT business compared to the smartphone business, and everything is different. The smartphone business, everyone uses their phone in many ways the same. They look at apps, they stream videos. Everyone uses their phone in pretty much the same way. But IoT devices are used in very, very different ways. And so we have this fragmentation of lots of different use cases with lots of different devices. And that makes the economy of scale of the IoT business very difficult to build. And I'll talk about some examples of that later on. But we have thousands of different modules required. Each one has low volume when the whole market adds up to higher volume. And also the service model, the IoT device in this oil refinery that I'm showing might be installed and expected to work for 30 years. But you tend to replace your smartphone every 3 years. So that service model and how things are used, and is it thrown away as a disposable device, or is it expected to just keep working, even with upgrades to other systems that are connected to it? Some of these things are quite different. And of course, the business model is different. How you make money off that wireless service. It's not always just a monthly fee for your IoT devices. It could be completely paid up front with lifetime services, or it could be paid by the use. So the business model could be very different in the IoT case. Okay, let's look at one example of this, and that is on the economic side. So in a high-end smartphone, like one of these flagship phones, you tend to sell in the range of 200 million units. And for each generation of phone, it might cost you somewhere in the range of $500 million to develop the ASICs for the app processor or for the modem. And so we're talking about something like $2.50 of amortized R&D cost for every smartphone. And that sounds okay, right? When you're buying your smartphone for $1,000, it seems reasonable that they've absorbed the cost of $2 or so into the cost of that phone goes to the R&D for the chip. That seems like a reasonable ratio. But now when we look at the IoT device market, we have that fragmentation going on, and the devices are simpler. They don't have to work over so many different interfaces. They might have multiple different frequency bands to work in, but they only have one use case. And so let's say the R&D for an ASIC might be in the range of $100 million. And that may not even be on the latest technology node. So instead of 3 nanometers, maybe we're working in 5 nanometers here. And so let's say we have a successful project where we sell 10 million units, which is pretty high in the IoT case. And so that puts us at $10 per unit of amortized R&D cost. That can be a problem when the module costs $10, but you're trying to sell the end device for something like $15. The math doesn't work out as far as the business model. And so that's one of the things that's slowing down the IoT business. People are only developing those applications where the module vendors make money and the service provider makes money and everybody else in the chain can make money. And so I think this is one of the pieces where people find they're unable to get the devices they need because the math just doesn't work for companies that make the modules. Now, to the topic of fragmentation, we have thousands of different markets, thousands of applications in each market. And I'll talk today about just kind of one differentiation between two different spheres of influence. And so if you look at the industrial markets, where it's things like the utility grid or construction or manufacturing, those tend to be IoT heavy sort of applications. Where we call it asset heavy applications that tend to be more outdoor in nature. So that's high power RF, and it's high reliability, and in some cases low latency applications. But on the carpeted enterprises, it tends to be more human focused. Maybe it's a point of sale terminal being used by a human user. And so maybe that's something that doesn't require the kind of latency or even the 5 nines of reliability that you would normally require in a manufacturing case. So I think in those kinds of cases, we have different applications, different power levels, maybe different numbers of frequency bands in the module. And so you can see it's very different use. Another way to look at this is in terms of the business model. Is it a network slicing model where the network operator is selling a service, or is it a dedicated private network with a radio on premises inside a building? And you can take companies like John Deere making tractors or Volkswagen making cars. They tend to go with the on-premises radio, so they can get the highest possible reliability, get the highest possible signal-to-noise ratio, and they have control over their data inside the four walls of their building. That's the approach they like. But a utility grid needs coverage over a wide area, and building their own towers and their own high-power radios to cover everywhere would be extremely expensive. So in their case, a network slice would make more sense. So we have a business model which could be bifurcated, some going to the operators and going into other applications with a different business model. Now here's a slide that just kind of shows the general growth in some of these different key markets, whether it's white goods or smart city applications or drones, automotive. There's significant growth in a lot of these different cases, but each one of these has unique properties. And one of the big questions is whether some of these can use a common module. Is it possible to have one IoT module that serves a lot of these applications? And so far that hasn't really worked out. There's been so much customization that there's been a lot of differentiation between each of these vertical markets. But there's some hope that could come into a common module in the future. So as I summarize really what's going on with the different aspects of the market and what's slowing down the IoT market from growing faster, I look at really the holistic view of enterprise adoption of automation. And you really need all the spokes on this wheel to be in place for the market to look good for rolling forward. And so what you see here is that we can have cases, a lot of the markets, we have a radio access network that's in place and the spectrum is ready, and we have edge computing, and we have a distribution channel and so on, but maybe the devices are missing. And so the readiness wheel has a bit of a flat tire. So one of my goals today is to explain how having devices that suit all these different purposes may actually be the catalyst that we need to make the IoT market grow faster and to go viral in a better way. Just a couple examples of this readiness wheel. I think the transportation market is one example where you look at something like automated cranes in a seaport, offloading big containers off of ships or something like this. A lot of the pieces are in place. The edge computing or the radio network could be in place now, but the devices have not been developed because maybe there's only so many cranes. If you're going to maybe sell 1,000 cranes, some kind of IoT module that's a specialized module, that's just not enough units to justify the investment for one of those IoT module vendors. And so the devices are still lacking in being able to handle these crane applications in all the different countries of the world. And so that's one good case where we think the market could grow if we had the kinds of devices in place that were ready for that. Now, another small market where I think there has been some success is in the mining business, where it's copper mines or bauxite or some of these other open pit mines where they automate the trucks and the excavation machines and so on. And they're using very simple LTE devices for that. They have not moved on to 5G because they've settled on a common sort of LTE module to automate a lot of these trucks. And people are using those trucks in lots of different countries and lots of different applications. And so this is something where a relatively niche market, open pit mines, all the miners are using the same technology and porting that technology into their own use. And so that market has been well developed because that has now been underway for many years, and all of the pieces of the puzzle are mature. Okay, so getting back to fragmentation and how we fix it, I think really we own a lot of this in the wireless business. The 3GPP community has created more than 20 different formats for connecting RF devices here. So we ranging from GPRS all the way up through 5G formats. And the problem is the old ones never go away. So we still have old soda machines that are still connected on GPRS, and they're never taken down because people in that business don't upgrade their technology just because. If it ain't broke, they don't fix it. And so we're going to continue to have some of those GPRS machines until somebody forces them to remove them. And so we have this fragmentation where module vendors have dozens of different formats that customers are asking for, and the old ones just never die. Now, about 8 years ago, I would have told you that the market was taking two different directions. There were some devices going toward faster speeds, faster all the time, and other devices where the focus was more on low cost. And at that time, we were developing Cat-M. Cat-1 was a thing. NB-IoT was happening in China. And so we had a lot of investment going in the direction of low-cost IoT devices. And if we had continued that trend, I think we would be in good shape today. But in fact, we didn't. What we started to do after 2017 is we started developing, things more toward higher speed instead of focusing on lower cost. So today we have 5G RedCap, where we move towards something like 80 megabits in the uplink, and so instead of going toward less capacity, less cost, we decided we wanted something that did everything but at a higher cost, and I don't think that really suited the business purpose, and that's one reason why you don't hear a lot of people talking about 5G RedCap or really latching onto it that well. For me, the cost reduction is really doubtful compared to Cat-1 or Cat-M devices. Now we have this new one. eRedCap is a step in the right direction. So that's where we're taking it back down toward 10 megabit uplink, which is giving them the ability to strip some of the real estate out of the silicon on the device, making a simpler device and simpler processing. And still, it's a 5G device, so it's still compatible with lower latency and network slicing and some of those business model changes that are happening. Still, I think cost reduction is doubtful. I think with eRedCap, we're still going to be more expensive than we are sitting with Cat-1 bits or some of these other formats, older formats. So, I'm not sure it's really the end answer, but it is a step in the right direction. And then the next question is whether 6G is really going to change anything. New spectrum means more fragmentation, and new wireless standards means, well, even more fragmentation. So I don't think that's really the solution. We tend to think that, okay, we have a problem, we need a new standard. I think in the IoT business, that's not right. The actual solution is to stop making standards, stick with something that's pretty good, and use economies of scale and use time to build that scale and depreciate some of the assets and make everything cheaper and get the cost down so you can address the whole market. So, in my opinion, there's a new business model needed for IoT. I think we need to get away from the 3GPP model of new standards all the time. I think there's many applications that might not have the volume to justify the R&D expense for a tailored module. So a common module, a universal module might be a good idea. Or in other cases, maybe we need the end customer to pay some NRE so that they get the IoT module that they need. For this oil pipeline that crosses two countries from Canada to the United States, maybe they need two different modules and they need 5,000 of one and 2,000 of another. That's not enough volume to justify the R&D investment for those modules. So I think that oil company that needs this pipeline may be the one to step forward with the money to pay the IoT module vendors to make sure it happens. And then again, we need long-term radio standards. I think we need standards that last for 30 years. We can't be dealing with new standards every 3 years. Okay, so this is a pre-recorded session, but I'm going to join live for the Q&A, and I'll be available in a few minutes when they start that up.